Okay, for example 3, this is a really long type of example. Finding the shortest route, depending what you're given, sometimes this can be a really long problem. So I gave you this example, which is the longest type of example, but there's so many ways to coming around to getting this answer that it might be a little difficult when you come time to do the practice questions. But I'll be back on Monday to help you guys out and try to figure out the shortest distance for problems that are not exactly the same as this one. Hopefully you can try to figure it out, but if not, then like I said, I'll be here to help you out. So for something like this, before you start doing any math whatsoever, you need to understand the problem. So you have a ranger cabin that is to be built in the flat wooded area near the straight road that connects the 2 campgrounds in a park. A new side road will connect the cabin to the campground road. On the park map, the campgrounds have coordinates A and B, not going to repeat them, while the site for the cabin is R6.01.5. Each unit on the map grid represents 500 meters. So the first thing you want to do is draw this and really understand that this cabin R needs to be built on the new road. So that new road is going to connect it. And what you want to do is you want to minimize the cost. When you're building a road or you're a company building a road, you don't want to spend tons and tons of extra money. You want to save money. So this is why you want to build the shortest possible road to the 2 campgrounds. So I'm going to go ahead and graph that. Here's what this looks like. We know there's already an existing road between A and B, so I'm going to go ahead and draw that between A and B. What we do want to do is build the shortest route from cabin R to A to B. So we want a road that goes from the cabin to this line here. So here's the thing. When it's the shortest distance, what you want to do is you want to draw a perpendicular line. Now that is extremely important. So it has to be a perpendicular line in order for it to be the shortest distance. So I'm doing my best here to draw a line that it looks perpendicular. Okay, so when you're doing this by hand, please use a ruler. Make sure you do your best to try to make sure that this is perpendicular. And if you can't, just put that little square, and that way I know you know that the shortest distance, maybe we'll write that down on the side, shortest route, for any example, shortest route equals perpendicular line. So this can be written in your block note this time, since I did put a section for it. So shortest route, again, the first step is knowing that it creates a perpendicular line to whatever line that you're doing this with. So I'm going to put a little dot here, and I'm just going to call this C. I can't call it M. M represents the midpoint, and this is not what this is. It doesn't necessarily go to the midpoint. So this is kind of a problem. You're putting all these concepts together, and you have to remember when you do the midpoint, when you don't. And in shortest route, you do not do the midpoint. It's for only the perpendicular line that's important right here. So this is basically the most important thing right here. So what we need to do is find the distance from R to C. Okay, and I'm just going to write down the formula to find the distance from R to C. So it's x2 minus x1 squared plus y2 minus y1 squared. Now the problem is, to do the distance, you need 2 coordinates. Okay, 2 given coordinates. Now we have coordinate R, and coordinate R is given 6.0, 1.5, but we do not have coordinate C. To find coordinate C, you have to find the point of intersection of lines AB and RC. So let's write that down as well. To find C, find the POI of lines AB and RC. So that's why this is complicated, because you need the point of intersection in order to do the first part, which would be the distance. Okay? So now, to find the point of intersection, you need a system of lines. So you need at least 2 equations. Okay? So this is basically the second thing you're going to look for. You're looking to find the POI. But to find the POI, you need your 2 equations. So we're just going to write that down underneath. Find equation for AB, and then we're going to find the equation for RC. Find equation for RC. Okay, make sure you label all of your work extremely properly. So let's go ahead and find the equation for AB. In order to find an equation, realize what kind of graph this is. So AB is a line that goes from A to B. So because it's a line, the general equation for a line is y equals mx plus b. And in this equation, you need to find the slope and you need to find the b. So let's go ahead and find the slope of line AB. The slope formula is y2 minus y1 divided by x2 minus x1. Should be getting pretty good at doing this by now. Your point A, I'm just going to write it on the side, is 2.0 and 8.5. Luckily, we have decimals, so you're allowed to keep the decimals. A lot of times in class, I don't allow you guys to work with decimals, but if the problem gives you decimals, you're allowed to work with them. So we're going to subtract the y's first. I always like subtracting the top y by the second y, but it doesn't make a difference. So 8.5 minus 4.5. If I divide by the top by the bottom, subtract the top from the bottom, I have to do the same for my x's. So it's 2.0 minus 10. Now if we calculate that, 8.5 minus 4.5 will be 4.0. And 2 minus 10 will be negative 8. Which means if I divide this, since I'm allowed decimals, thankfully, the slope of AB is negative 0.5. Now, we need to find the y-intercept as well. In order to find the y-intercept, you need to know where the y-intercept is found. And the y-intercept is the letter b, which is found in the equation y equals mx plus b. Since we're looking for b, I need to have a y, an m, and an x for the line you're looking for. So this is all for the line AB. Okay, it tells us right here the equation for AB. And we just did the slope for AB. So we've got the slope, which is negative 0.5, and we've got an x, and we've got a y. Actually, we have two x's, and we have two y's, because on the line AB, there are two of these coordinates. There's A and there's B. Two coordinates on this line. Actually, there's three. There's the C coordinate, but we don't have that yet. We do have A and we do have B. So we're just going to pick one of them. I'm just going to go ahead and pick point A just for fun. So the x value of point A is 2.0, and the y value for point A is 8.5. So just to show you, I took this from point A. So we just sub it in. So my y value is 8.5. My slope is negative 0.5. My x is 2.0. And then I do plus b. So when I calculate this, I do negative 0.5 times 2.0 to start with. Negative 0.5 times 2.0 is negative 1. And then remember that we're solving for b, which means we need to add 1 to each side, which gives us 9.5 equals b. That's just the y-intercept. So at the end, remember that we're looking for the equation. The equation of AB is y equals negative 0.5x plus 9.5. That's the equation for AB. Okay. Now we need to do the equation for RC. So if we go look back, there's no possible way of using the slope formula because you need two coordinates to do the slope formula. I only have one coordinate, which is coordinate R. I don't have coordinate C just yet. So I can't actually do the slope, which means that the reason why this is perpendicular is it's there for a reason. When lines are perpendicular, you use the negative reciprocal. So the slope of RC is the negative reciprocal of AB, because those two lines are perpendicular. So if the slope of AB is negative 0.5, that's negative 0.5 over 1. That means that the slope of RC will be, you do the reciprocal, so that means you flip, and then you add a negative to this slope. So if I add a negative to what's already negative, I'm going to have two negatives multiplied, which gives me a positive. Another way of looking at that is if one of them is negative, the other one has to be positive. That's probably the easiest one. So make sure they're not both negative or not both positive. One needs to go down and the other one needs to go up to create those two lines being perpendicular. If you take a look at slope of AB, it makes sense. The slope of AB is going down from left to right, which means why it's negative. The slope of RC from left to right is going up. So if you check your answers, it will make sense. Now, when you divide 1 by 0.5, you get 2. Okay, 1 divided by 0.5 is 2. So now we have the slope of RC. We just need to find the B value. And remember where we find that B value, it's in y equals mx plus b. In order to find b, we need the slope, which we just found. It's 2. We need an x and we need a y. But we need an x and a y that's on the line of RC. Okay, it's super important to make sure that you get all your information from the line that you're working with. So right now we're working with RC. And if I go to RC, the only coordinate I have is coordinate r. So I'm going to use those coordinates, which is 6.0 for x and 1.5 for y. So that's point r. So let's fill it in. Y is 1.5. Put the equal sign. The slope is 2. The x is 6.0, and then you write plus b because that's what you're looking for. 2 times 6 is 12. To cancel out 12, you do minus 12 on both sides, and you get an answer of negative 10.5 for the y-intercept of line RC. So now we just write, therefore, the equation of RC is y equals, the slope was 2, and the y-intercept was negative 10.5. Okay, so we have two equations, which means we can now do method of elimination or method of substitution. Now, both equations are already isolated, so I would tend to use the method of substitution. So since they're already isolated, I don't need to write find the isolated variable. They're both already isolated. So I'm going to go ahead and substitute. I'm going to label these now. That's going to be equation 1 for me, and this one's going to be equation 2. Okay, I'm going to substitute 1 in 2. So I'm going to take this y value, and I'm going to go put it where this y is, right here. Okay? So I'm going to have negative 0.5x plus 9.5 equals, and then I rewrite the rest of equation 2. So basically, when both y's are isolated, you could put them equal to one another. We're just going to solve for x. To solve for x, there's x's on both sides here, so cancel one of them out. I'm going to go ahead and add 0.5x to both sides, just so it doesn't create any negatives, but it doesn't matter which way you want to do it. Okay? So if you have x's on both sides, make sure that you cancel one of them out. Not move, cancel, in order to find it and only have one x. Now here I'm looking for 2.5x, so we're going to add 10.5 on each side because that 10.5 is in the way. Do not divide until the very, very, very end. So now we have to add 9.5 and 10.5, which gives us 20. And that equals 2.5x. At this point, we can divide both sides by 2.5. And when we do that, we get x equals 8. So we get a nice value for x. Now we just need to find the y value. And remember that this is the x value of point C, because this is the point of intersection that we're doing now. We're using the method of substitution to find point C, to find the point of intersection, which is point C. So we're going to sub x equals 8 in one of our equations. I'm just going to go ahead and put it in 1 since it really doesn't matter. Equation 1 was y equals negative 0.5x plus 9.5. So when I sub that in, I get negative 0.5 times 8 is 9.5. When I multiply those, I get 4.